Okay, so Harmony Core is one way that we've got of exposing data and logic and stuff in real time. Another way is replicating data to a relational database. So this is something that's been around quite a long time. For a lot of you in the room will be a refresher. I know some of you have seen this presentation at the conference before, and we've been presenting about data replication from Synergy data to relational databases for many years. So this session originally from the conference last year was intended as a kind of update to that. So a lot of it is just updated information. Basic principles, if you have not seen this before, and I know some of the people in the room haven't seen this before and we're specifically interested in it. The basic principle here is we're interested in saying my application has got a whole bunch of data sat in its Synergy files, be they ISAM files, relative files, whatever, and we would like to cause that data to be replicated into a relational database so that we can do other things with it, so that we can report on it, do data analysis, do data warehousing, whatever it happens to be. And we would like that data to be updated as quickly as possible when the application data changes. So it's not real time, but it's very close to real time. So that SQL database is pretty much an accurate representation of the state of the application's ISAM and relative file database at any given point in time. So what we're going to do in this session is give you an overview of how the process works, give you a quick demonstration of how it works. It's pretty much a well understood and well defined process at this point. We've got it really down to a fine art. It's the sort of thing that used to take, well, in the early days could take a couple of months to get up and running. In more recent years we got it down to a couple of weeks, and now really we've got it down to typically a few days if you want to implement this kind of stuff. As long as the reference environment that we've built matches what you need, then it's almost trivial to implement now. So the basic principles are that we're going to take data from one or more files in your application, your existing data files, and we're going to replicate them to matching tables in a relational database. We're going to do that in close to as real time as possible, typically within a few seconds of your application, a small number of seconds, typically 1 or 2 seconds of your application changing something. That change has also been made to the database. We are talking one-way replication, so there is no concept of updating the data in the database. It's simply there for read purposes and for reporting, analysis, whatever. If you want to update data back, then using a Harmony Core service to update that data would be a very acceptable way of doing updates back into the data, and those updates would then get reflected back out to the database in near to real time. We're looking for something that's easy to implement, so we're talking typically days, not weeks. We're looking for a way of doing this with very minimal changes to your existing code, so we're not expecting or requiring any significant work to happen in your applications. We're looking for minimal performance impact on your original application and minimal cost of doing this as well. So those are the criteria and what we're trying to solve, the problem we're trying to solve. The approach is that we provide a core environment that we've worked on over many years now. This thing's been evolving literally for over 10 years since it was first built. So we provide a pre-written core environment that does a lot of the work for you. A lot of this, like Harmony Core, is also based on code generation. So we require that you define your ISAM files, their record layouts, and their keys primarily in the repository, and then we can help you generate the code that's necessary to interact with the relational database for those files. Once you've got that generated code in place, and really the requirements for repository for doing replication are really just files, records, and keys. Maybe tags if you've got multivariate record format files, but you don't have to get into all of the relationships and stuff that Harmony Core requires. Even if you don't have a repository, doing the stuff that you need in the repository for replication is very straightforward. Once you have that generated code, we simply plug a small amount of code into your application, and that basically utilizes I/O hooks. So typically the one change you have to make to your application is whenever you open the files, and very often, most people have a subroutine that they use to open files. So that's the one place in your code that you have to touch. And when you open a file for update, you add one line of code to say, give this channel some I/O hooks. And that's how we plug in functionality at the channel level. And from that point on, our code just exists underneath yours. And whenever you change anything in the file, we take whatever action is necessary. How the replicator works, there is a single detached process that does the replication work. So the work of talking to the database is not done in your applications at runtime. What happens is the I/O hooks code that we plug into your application simply record change events into a queue. And that queue is an ISAM file. It's a very simple environment. So the extra overhead on your system is writing instructions to that ISAM file queue. And then there is a detached process which comes along and simply polls that queue periodically, saying, did anything change, and makes the appropriate change into the relational database. And then it goes to sleep, wakes up a few seconds later, and does the same thing again. So that one process is talking to the database, looking at any changes your application makes to your data and pushing those changes to the database. It's a very simple process. Okay. The Replicator capabilities, so what can it do? The Replicator has the ability to create the initial tables in the database. It has the ability to add indexes to the tables based on the keys that you have defined in your files. It can also delete indexes and tables. It has the ability to load initial data into the file, so you don't have to do anything with the database. It takes care of creating the tables, loading the initial data, and then it starts doing replication. It also now has the ability to do bulk load, and I'll explain what the difference is between that and a regular load in a little while. And it has the ability to delete all the rows, so if something gets out of sync and you need to resync the data, you can send it instructions saying, get rid of everything in the customer file and reload it. Typically that doesn't have to happen. We've got customers who are using this stuff heavily. Probably the biggest one so far is a customer that uses it on a subset of their files. I think they have about 30 of their main files that they replicate, but it is a 3,500 user system at this point in time, and they are pushing tens of millions of changes a day through the thing, and it's behaving just fine. And they do not have to touch it, pretty much. The basic capabilities are just insert row, update row, delete row. And as it sees your application creating a new record, it inserts a row, it updates a row, it deletes a row. So that's what it's doing most of the time. There's also a few management things. You can tell it to change its polling interval, you can tell it to cycle its log file, and various things like that. But so each of these are the individual instructions, things that the replicator can do for you. I'm just going to give you a quick demonstration so that you understand what this thing does. Everything is in GitHub. Normally I start from absolute scratch and clone the repository and so on, just to save a little bit of time. If you go to the URL, which is github.com/synergex/SQL replication, and just clone, this is what you'll get. There's a Visual Studio solution. This is all traditional Synergy. There is a Visual Studio solution. There is also a Workbench project, so you can work either way. If you prefer to use Workbench, that's fine. And essentially there's an ELB with a bunch of stuff in it. Some of this stuff is pre-configured, some of it is code generated. The one bit that's code generated is per file. We generate, my demo environment has one file, it's the employee file. So we've got employee SQL IO. And this is the one part that's generated. So for each one of your files, we code generate a subroutine or a function that says, does the table exist in the database? And it's just SQL connection code to say, does the table exist? We generate a create the table. There's the SQL create table command that gets executed. We code generate a add indexes to the table. I realize I'm going very quickly, but you can look at this code at any time. It's all out there. Remove indexes from the table. Here's the important stuff. Insert a row. So it takes a database channel and a record, and it does a insert into employee, blah, 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 blah. This just takes a record, inserts it. Okay. There's also a routine that's generated that says insert multiple rows. There's a routine that's generated that says update a row, delete a row, select a row, and so on. So there's about 15 functions get generated for each of the data types. All of them: create table, delete table, add indexes, insert row, update row. And the replicator just calls these things by name. It simply says, oh, I see an insert for the employee file, therefore I'm going to call employee insert, and I'm going to pass it the record. And this generated code does that. So the replicator just looks at names and says, oh, call employee insert, product update, order create, and it just sits there all day playing the instructions to the database. So there's the library ELB. The replicator process itself is pre-written. It's in replicator.dbl, and it just does its thing. I'm not going to linger on this. It just has a processing loop. It opens up the queue file. It says, what do I do next? X call that routine. What do I do next? X call that routine. It's really simple. Okay. Just to give you a demonstration of it actually working, if you open up the sample project and build it and then run replicator menu, which is a little development management testing type of thing. So this is just a little test program. I've done some pre-configuration so that there's a connect string that identifies where my database is. It's pre-configured for a local SQL Server database named SQL Replication, which is here. And I know it's hard to see, but here's the tables node, and there are no tables in the database. This is a totally empty SQL Server database at this point in time. Okay. If I start the replicator process, which I can do by going to my menu and saying SR, now normally I'd run it as a Windows service or a cron job or an at job on Linux or a detached process on OpenVMS. I'm just running it as a desktop app just so we can see. If you run it on a terminal, it logs to the screen, and it's just, for demo purposes, it works well. So this is the replicator running, and it's just processed its settings and set a few things up, and it's connected to the database, and it says processing instructions. So in the background, as you can see, I've got my interval set to 2 seconds. So every 2 seconds, this thing's just waking up saying, anything to do? No, sleep. Anything to do? No, sleep. Okay. If I give it something to do, for example, if I go into here and say, let's run a fake little maintenance program. So this is faking out your application, some part of your application. Oh, Windows 10 shake. Okay, didn't want to do that. Okay, so here's the replicator. Here's my maintenance program. Just to show you the sort of things it does. If I say I want to amend an employee, and I'm going to change Jose's last name, whatever, to something, let's just do something we can recognize, A, B, C, D, E, and I'm going to say exit to save changes, and the replicator within 2 seconds is going to wake up and do something. So it's going to say, oh, okay, oh, I've got an instruction for employee. This is the first time I've encountered employee. Let me go and check the database and make sure the table is there. Oh, it's not. Okay, let's create the table. Table was created. Now we'll do a bulk load. So it inserted 25,000 rows into the database. So it read the whole file, inserted it into the database, added indexes, and now it started replicating. So the point of this is that the replicator is totally generic. All it saw was employee file, insert, call that routine. Okay, and that routine said table not found. So it has the ability to set things up for you. You don't have to pre-create the database or anything like that. If we now go to the database and do a refresh, we should see that we now have an employee table, and if I select data from it, we should find we've got all the employee data in there. And I'm not going to go, well, I'd selected the top 1,000, but there's 25,000 rows in there now. Okay, so now that table is up and running, and you can see the last name is ABCDE. Now we're in kind of normal processing. So if we go back to our maintenance program, and you can see the replicator there, it's just sat there doing its thing. It's checking every 2 seconds. We go back to that employee and change the last name again. And again, exit to save changes within 2 seconds. Oh, it did it already. Okay, so it updated the row employee, and if we go back to the database and refresh the data, you can see the last name is back again. That's it. Okay, I'm not going to demo any more than that. That's the basic principle. Like I say, it's all out there on GitHub for you to grab and use. If you haven't done this and want some help with this, give us a call, and we'll get online with you and help you. So that's basically an overview of what it does. It is supported on all platforms. We do regularly test it, and we've got customers running it for real on VMS. We've got customers running it for real on Linux systems, on Windows systems, and so on. So to get up and running, you need a repository. You need structures, keys, tags, and files. So it's a fairly basic repository setup in order to get up and running. I typically, if I were doing this for someone, I would expect it. Chris is quoting 20 minutes to set up the repository for a new structure. I would say in most cases that's about right. It might take a little bit more if there's some files have 25 keys, and that can take a while to define. But typically, 20, 30 minutes to get a new file defined in the repository, generate the code, and you're up and running. So literally the process is define the repository. Just like with Harmony Core, there's a batch file provided. You just list the structures that you're generating code for. You generate that code. There is one file that you have to edit, which is a routine called configure replication. And as you add new files into the environment, you have to go and detect when this file is opened, add the appropriate IO hooks, either ISAM or relative. So that's literally the extent of the change. There's one file to edit to add a new file to the replication environment, and that's pretty much it. In terms of things that have changed, if you've been familiar with this, just recent things that we've changed to improve the environment. Previously, in earlier versions of this, our Q file used to use an A20 key, which was filled up with a %datetime value. Turns out that a %datetime value, a lot of stuff can happen in the context of that time frame. We were actually getting duplicates all over the place, so we modified it recently to use an I8. In version 10 of Synergy, there is a auto-incrementing key. So we now just use an auto-incrementing key, which is an I8 value, and we got dramatic throughput improvements as a result of that simple change. So there was quite a bottleneck that has gone now. This is talking about that same thing. ISAM file key requirements. In older versions of this, we used to require that every file had a unique primary key. And if the primary key was not unique, we required you to go and add a specific key to the file. Now what we do is we go looking for a unique key. So as long as each file has at least one unique key, it doesn't have to be the primary key anymore, then you don't have to touch the file at all. So the only time you would have to touch a data file and change its layout is if you have an ISAM file that has no unique keys whatsoever, which is pretty rare. So generally speaking, you can implement this stuff with indexed or relative files without having to make changes to any of the files. We did add relative file support. That was not there until recently, but it is now fully supported. Essentially, we just add a virtual row number column to the beginning of the record and treat that as a primary key. So in the database, the row number is used as the unique ID for the environment. We also added something new. If you're running, we target primarily SQL Server, although with a little bit of tweaking, we could target other databases as well. But this is pre-set up for SQL Server, which kind of implies that you're on a Windows database server. So we invented something called File Service, which is a little Windows service that you can run on the database server. And if you choose to do that, it opens up a new load mechanism for the replication environment to use called bulk load. And essentially loading initial tables will be about 20 times faster if you choose to use this mechanism. So essentially the way that loading a table used to work is it would literally read records from the ISAM file. I think it would read 1,000 records and then do 1,000 inserts into the database and read the next 1,000 and do 1,000 inserts. What bulk load does is it exports the entire ISAM file to a delimited format, and it uploads that file to the database server via the file service, and then it does a bulk insert from the local file on the database server, and it's dramatically faster. And we found we can actually bulk load some enormous tables really, really quickly with that mechanism. So bulk load, and again, so that was a side effect of the file service. So if you are using the older environment and you're still doing the old load mechanism, you want to look at switching to bulk load. It's literally like 20 times faster. Another thing we changed recently is the approach we used to take when doing this stuff was the templates that were generated would, every time you created a table in the database, it would immediately add all the indexes to that table, which meant that doing your bulk load, all of those indexes had to be updated for every insert that happened. So we found that by suppressing that and actually not creating any indexes on the table until the load had been done, and then as a separate function adding the indexes, we actually got a fairly dramatic improvement in, again, initial load performance. So again, if you're using the older version of the environment to do your replication, you might want to just pull the latest templates and regenerate the code and pick up the new stuff. There's another little change that we made to do with clustered indexes. So clustered indexes in SQL Server define how the physical data is organized and stored in a database. For SQL Server, essentially primary keys must be unique. So essentially, if we were replicating based on an alternate key, so if the primary key was not unique, we were not taking advantage of making any clustered indexes. Now we do. So if we defer down to a second or third or fourth alternate key, because that's the unique one that we use to synchronize the file with the database, we make that key a clustered key, which again is resulting in better read performance in most cases. We also made another change fairly recently, which is the way we commit data to the database. Initially, and through about a year ago, every time we went to the database, we would immediately commit whatever that change was. So if we were doing 100 inserts in a row, we'd insert and commit, insert, commit, insert, commit. And we went through a few flavors, but what we wound up with was, by default, we now use something called batch commit. And essentially what batch commit does is it allows the replicator to do multiple things to the database and then commit as one big blob at the end when it's done. So there are three things that will cause it to commit now. One is if the replicator has done a bunch of stuff and then runs out of instructions, it will commit everything it's done before it goes to sleep. Or if it hits a batch size limit, so we default to saying every 1,000 entities changes, commit them as a block. Or if there's a major event like a new table that gets created or something like that. By deferring to batch commits, again, we got a fairly decent bump in performance overall. There's a new shutdown mechanism if you're using this environment already. In some of the older versions, whenever you told the replicator to stop, it would just write that stop instruction in the normal queue sequence. So the replicator would have to work its way through the instruction queue until it hit that point and then stop. And if there was a lot of stuff in the queue, that could take a while. So what we now do is we encode the stop instruction in whatever the first instruction in the queue happens to be. So the next instruction the replicator encounters will cause it to stop if you tell it to stop. Might not be immediate still because the replicator might be in the middle of doing a bulk load or something like that, so it's not necessarily instantaneous, but it's a lot better than it used to be. Another change we've made recently is it's now possible to run multiple instances of the replicator. So a lot of our customers have different data sets on their systems for different companies or different sets of data, whether it's in different accounting entities internally or different customers that they're hosting for or something like that. So now you can run multiple instances. You can apply a name to each instance. This is not a way of improving throughput and scalability within a data set. It's still pretty important that for a given data set you have an instance of the replicator to ensure that you maintain the correct sequence of changes that happen to the database. It really is for if you have completely different data sets for different companies, then you can now have a replicator per data set. Optional data cleanup. It turns out that it's surprisingly common having, and this is sometimes a problem in Harmony Core as well. It's surprisingly scary actually how often we have bad data in ISAM files. You know, numeric fields that don't have numeric values in them, and dates that don't have date values in them, and times that don't have time values in them, and that sort of thing. So just be aware that by default, if you're using replication, by default, we turn on a whole bunch of data cleansing operations. So literally, as we're dealing with a row or a record, we're looking at every numeric field and saying, does this numeric field have a numeric value? Does this date have a real date in it? Does this time have a real time in it? And there is some overhead to that. It's actually not as bad as it sounds, but there is some overhead. If you know your data is clean, then there is a way of disabling that stuff, and you can get quite a good performance boost by doing it. But by default, because we've found through experience that most people tend to have some questionable data out there, we do go through that cleansing operation all the time. And that's also important that you understand that if we encounter a numeric field that has a bad value, all we can do is set it to 0 or set it to some value, and we choose 0. So by default, there's no guarantee that the data in the database is actually the same as the data in your ISAM files, because if that data is bad, we'll insert a 0 instead rather than failing. You can control all of this through settings as well. Configuring Replicator, there are now 2 mechanisms to do this. It's always been done historically through environment variables, but there is now an alternate way of configuring it through command line options if you wish. So there's like 20 or 30 different settings, and they all have command line options now, and so on. We've also done a lot of work on logging, both the quality of information that's logged and how the logging works. Previously, the replicator was opening and closing the log file every time it tried to or wanted to log anything, which is fine if you've got a low level of logging enabled, and it's fine if your system isn't that busy. But it turns out when you get up into 2,000-3,000 users worth of stuff, the fact that we're opening and closing the log file every time actually became a major performance bottleneck. So now we open the log file and it remains open for the lifetime of the replicator instance. The downside of that is it's not as easy to look at the log file, so there is now a mechanism to tell replicator to close the current log and open a new one, so that you can go and work with the previous version of the log file. So again, if you're using an older version of the software, that might be something you want to look at. You could potentially get a performance boost. Another thing we've added recently, or fairly recently, is email notifications. So again, it's configurable, but you can point it at an SMTP server and you can give it various email addresses for sender and recipient and so on. And it can generate email notifications for certain types of events that are listed on the side. It's not data level stuff, it's major operations that tend to generate things. It's the replicator starting and stopping, new tables getting created or major errors, that kind of thing. It's not sending emails about routine stuff. There is also an option to cause the replicator now to stop if it encounters a problem. Because one of the worst things that can happen is if it does encounter a problem, and these problems tend to be data related, it fails because of some weird piece of data in your database, it can be really tough to figure out where it was at that point in time and get things back in sync. So most people that are running this stuff for real do configure this and say, if you ever encounter a problem, just stop. And by the way, now it's going to send you an email and say the replicator stopped because. And the nice thing about that is that you can look at the first item in the queue, which will be the thing that caused the problem, and you can figure out what the problem was. The queue is still backing up and building up, so you're not losing any data. You're just losing the synchronization for that point in time. So you can at least have an opportunity of fixing the problem and then just restart the replicator, and hopefully it will just carry on from where it was at. It may take some time to catch up depending on how long it was down, but it's better than having to start over and delete tables and resync because you're not sure where things were. Database cursor use. We've also done a lot of work recently in how we use cursors. A cursor in SQL Connection is something that represents a SQL command. In SQL Connection, if you want to interact with a database, you open a cursor, execute the cursor, and close the cursor again. So it represents a SQL statement. There's some overhead to opening and closing these things, so we're a little bit smarter now about how we do that. And for the very frequent operations, inserts and updates primarily, we tend to open a cursor for that particular function for a particular table, and then we keep that thing around most of the time, unless we get into a very high number of cursors, in which case we might trim them down. But generally we try and cache things so that we're not opening and closing. And again, that can lead to a noticeable improvement in performance. So again, if you're using an older version, you might want to reconsider getting the latest stuff. We've also exposed the ability to configure things like max columns and max cursors. These are just some SQL Connection parameters that have some maximums on things that some people were running into. So we've given you a way of increasing those things if you need to. The replicator menu utility, just be aware of it if you start out with this environment. It's not intended to be a production thing, although some people use it for that. But it does give you the ability to say, start the replicator, and you can pump commands into it. So you can use this little utility to say, go create this table, go bulk load this table, delete all the rows, start over, refresh it. So it can be a useful little utility. And yeah, the other thing we've done is we've fairly significantly reduced the amount of code that's generated as well. We used to generate specific IO hooks classes for every file and a bunch of other stuff. Now we basically just generate the SQL code. Everything else has been refactored to be generic. So there's a lot less code generation going on than there was. Availability and documentation, again, everything in this whole environment. So you can find this thing at github.com/synergex/SQL replication. And a good place to start is the wiki, because there is some documentation that walks you through the sample environment and explains how to download it, how to build it, how to configure it, how to set up all the options. If you've got SQL Server locally on your development system, and if you've got a default instance of SQL Server, everything is pretty much pre-configured to work out of the box. It's really only if you've got remote servers or different authentication that you have to set a few options to get up and running. Again, there's the main repository if you want to grab the thing and have a play, Synergex SQL replication. And again, there is a Visual Studio environment, there is a Workbench workspace. There is also a Linux folder that has various bash shell scripts that you can use to build and run everything on Linux. And there is a VMS folder that has some VMS command files that you can use to build and run everything on a VMS server as well, if you want to. If anybody does want some help, these are just a few, how to go about getting up and running. These are in the wiki documentation as well. I'm going to blow through right to the end. Basically, all I'll tell you is, if you want to get up and running with this stuff and you haven't done it so far, and you want a bit of help, just give us a call. We'll get on a go-to-meeting, we'll spend an hour, and that's enough literally to get you up and running and show you how to do it. The only prerequisite is have a SQL Server database around somewhere, and we can easily help you get up and running with the stuff if that's in place. All right, thank you. Sorry we're a little bit over, but